In this video, I'll explain about onto function, which is also called as surjective function. A function f from a to b is said to be onto or surjective if for every element y belongs to b, there exists at least one element x belongs to a such that y equal to f of x. Or in other words, I can say it as for every element in a codomain, we can find at least one element in a domain such that that element is the pre-image of the element in the codomain, or else range of that function, if it is equal to codomain of that function, then we call that function as surjective function or onto function. The condition is every element in the codomain should have at least one pre-image in the domain. It can be more than one pre-image, not a problem, but the basic requirement is it should have at least one pre-image in the domain. See, for example, let us consider the first arrow diagram. 1 goes to 5, 2 goes to 6, and 3 goes to 6. Here every element in the codomain is having at least one pre-image. 5 is having the pre-image 1, 6 is having two pre-images 2 and 3, but the requirement is at least one pre-image in the domain. That is satisfied, hence this function is onto function. Or else range of this function is 5, 6, which is equal to the codomain of the function, hence it is onto. Second example, 1 goes to 5, 2 goes to 6, 3 goes to 6. So in this case, 7 is not associated with any element of the domain. 7 is not having any pre-image. Therefore, the condition of onto function is not satisfied. Here, therefore it is not surjective function. Or else range of this function is 5, 6, which is not equal to the codomain, hence it is not onto. Third case, 1 goes to 4, 2 goes to 5, 3 goes to 7, but 6 is not having any pre-image in the domain, hence it is not onto function. So this is what the definition of onto function. Onto surjectiveness requires every element in the codomain. Function definition says every element in the domain should have association in the codomain, but here in the case of surjective function, every element of the codomain, we are concentrating on codomain, should have at least one element in the domain. Now if you want to calculate number of onto functions from a set A to a set from if f is a function which is from A to B, and if you want to calculate number of onto functions, then the formula is given by n of A is equal to m, n of B equal to n, number of elements in A is m, number of elements in B is n. It is 0 if n is greater than m. If number of elements in the codomain is more than number of elements in the domain. So you can check this example here. Number of elements in the codomain 4, 5, 6, 7, 4 elements. Number of elements in the domain 3. So in this case, we can never form any onto function. Though you can have some other associations between the elements of domain and codomain, it is impossible to have any surjective function because we are forced to leave one element, because we can't have associations more than one. 3 can't be associated with 7 and 6 at a time. Then that basic definition of function only fails. So we need not check for ontoness. Therefore, if number of elements in the codomain more than number of elements in the domain, the number of onto functions 0. If n is less than or equal to m, in that case the formula is n to the power m minus summation k equal to 1 to n minus 1 to the power k minus 1 n c k into n minus k to the power m. This is in the case when n is less than or equal to m. Number of elements in the codomain is lesser than or equal to number of elements in the domain. Example, if A has 4 elements and codomain has 3 elements, then total number of onto functions is calculated like this: 3 to the power 4, that is, this is m, this is n, 3 to the power 4 minus 1 to the power 1 minus 1 is 0, 3c1, n minus 1. So n is 3 minus 1 to the power 4 plus minus 1 to the power 1, 3c2, 3 minus 2 to the power 4 plus minus 1 whole square, 3c3, 3 minus 3 to the power 4. up to k is equal to 1 to 3 in this case. When you simplify all this, you will get the answer as 36. There are 36 surjective functions possible from a set which has 4 elements to a set which has 3 elements. Now there is one more shortcut formula. If n of a, number of elements in the domain, is equal to m, and number of elements in the codomain is equal to 2, that's a particular case, then number of onto functions from a to b is given by the formula 2 to the power m minus 2. Now let us consider some examples to check whether the given function is a surjective or not. You have a function f from n to n given by f of x is equal to 2x, that every element is mapped to the multiple of 2. There exist natural numbers like 1, 3, 5, 7 and so on in the codomain which do not have any pre-image. So this is what the explanation for not being onto. See, for example, domain is also natural numbers, codomain is also natural numbers. Now one, as per the rule that 1 goes to 2, 2 goes to 4, 3 goes to 6, 4 goes to 8 and so on. Now in the codomain there are few elements which are left out, in the sense they do not have any pre-image in the domain, because 1 is not having any pre-image, 3 is not having any pre-image, 5 is not having any pre-image. So therefore what happens is this function doesn't satisfy the requirement of surjectiveness, hence this function is not onto. Or else in other way, range of f you calculate, that is 2, 4, 6, all even multiples of 2, all multiples of 2, that is 2, 4, 6, 9, which is not equal to the set of all natural numbers. Hence this function is not onto. Second case, second example, if I change the domain and codomain, I had the domain as natural numbers and codomain also as natural numbers. If I change the domain and codomain to real numbers, f of x equal to 2x, in that case it becomes onto. That is because onto, in the sense, for every element in the codomain, you take any element in the codomain, y belongs to r. There exists x belongs to, we can find one element in the domain such that f of x equal to y, that x is the pre-image of y. This is what the meaning of the condition. Now f of x is nothing but 2x, substituted here, equal to y. You have to solve for x. X is equal to y by 2. X means pre-image, y means image. We have to find out how the pre-image looks. Now pre-image looks like x equal to y by 2. Okay, y is a real number, y by 2 is also a real number. Clearly it is a real number. Therefore every pre-image, image is looking like 2x, every its pre-image looks like x by 2. So x by 2 is also a real number whenever x is a real number. Therefore automatically every element of the codomain will have a pre-image in the domain. So that is, if you take 0, it is mapped to 0. If you take 1, then put it over here, 1 by 2. 1 by 2 goes to 1. If you take 2, goes to 1, 2 by 2 is 1, 3, 3 by 2, then 4 is having the pre-image 2, 5 is having the pre-image 5 by 2. If you consider any real number for that matter, all those real numbers will have pre-image in the domain, hence this function becomes onto. Though the function is same in both the cases, I have changed the domain and codomain. Third example is modulus function. Modulus function is absolute value function. If you consider the modulus function f of x equal to mod x, this is not onto because it is a function from r to r, reals to reals. Now range of modulus function is all positive real numbers, all positive real numbers including this 0, which is not equal to the set of all real numbers, that is codomain. So you know the graph of the modulus function will be in the V shape. This is the graph. It covers only the positive y-axis. It is not covering the negative y-axis. So the outputs are not entirely equal to the real numbers. Hence this function is not onto function. Last example, f from r to r given by f of x equal to x square. This function is also not onto function. That is because you take the function value as y equal to x square, then solve for, because y is nothing but x is mapped to y, x goes to y means y is the image, and where y goes to this x means it is the pre-image. So you have to take the function as y, solve it for x, that gives you how the pre-image looks. Now pre-image looks like this, x is equal to square root of y. Now this kind of pre-image, is it there in the domain, that we have to check out. So y is taken from, y belongs to R. This R is nothing but it is codomain. I have taken an element from the codomain. Now I got the element which should be of the form square root of y, and that should be in the domain. I have to check for all possible values of y in from the reals, is it possible to have such an image, such an preimage? That is not possible, because if you take y equal to -2 and put it over here, -2 is a real number, x comes preimage comes out to be square root of -2. Square root of -2 is imaginary, it's not a real number, doesn't belong to R, hence this function is not surjective. There are few real numbers like negative real numbers which are not having any pre-image, hence this function is not surjective. So these are a few examples for surjective functions, and this is the definition of surjective function. The surjectiveness concentrates on the codomain, and it says that every element in the codomain should have at least one pre-image in the domain. Images are always in codomain and pre-images are always in the domain of the function. I hope you understood the concept. Thanks for watching.